All right, so we're diving into some fascinating research you've been looking into about whether those multimodal large language models can really understand what they're seeing and hearing, these MLLMs as they're called.
Right.
And the paper is titled AV Odyssey Bench. Can your multimodal LLMs really understand audiovisual information?
Yes.
And even just glancing at it, I was intrigued. It tackles some really big questions about AI, like can it watch videos? Can it listen to music? Can it even understand memes? But is it really understanding these things?
Yeah.
Or is it just picking up on these surface level patterns?
That's a really great question, and that's exactly what this research is trying to figure out. The researchers, they didn't just want to assume that these MLLMs understand, so they designed these really clever tests to kind of push these AI systems to their limits and see what they're really capable of.
Okay, I'm hooked. What kind of tests are we talking about?
Well, they started with something called DEF test, and
Test.
yeah, which focuses entirely on evaluating an AI's ability to listen.
Def test. That seems kind of counterintuitive. If these models are supposed to be handling both audio and visual input, why focus just on the listening part?
Yeah, so it's all about finding the potential weaknesses in their foundation. The researchers figured if an MLLM can't handle like basic auditory tasks, it's probably going to struggle even more with these really complex audiovisual problems that we're asking them to solve. It's like imagine you're trying to build a house, but the foundation is shaky.
Right.
It's just not going to work very well.
Makes sense. So how did the AI do on this deaf test? Were they auditory aces or were they tone deaf disasters?
Yeah, well, the results were surprisingly bad. They gave the MLLMs 4 tasks, counting sounds, comparing the loudness of 2 sounds, comparing pitch, and comparing durations. Even Gemini 1.5 Pro, which was the best performing MLLM, only managed an 81% accuracy rate on the sound counting challenge.
81%. For AI that's supposed to be so advanced, that's kind of a shock.
Yeah, and it gets worse. When it came to figuring out which of 2 sounds was louder, all of the models scored below 65% accuracy.
Yikes. So if AI can't even handle basic listening, how can we expect it to understand a video with all of its complexities of sight and sound?
Exactly, and that's where AV Odyssey comes in.
Okay.
Think of it as DEF test, but supersized.
AV Odyssey. Sounds epic.
Yeah.
Lay it on me.
It's a massive benchmark. We're
Okay.
talking 4,555 questions across 26 different tasks and 10 domains. It covers a huge range of audiovisual challenges.
All right, I'm really intrigued. Give me some examples. What kind of questions are we talking about?
Okay, so for example, in the music domain, the AI had to identify singers based on their vocal timbre, match music to different band styles, and even identify if an instrument wasn't present in a musical piece. So that last one is super interesting because it's testing for hallucination, where the AI might perceive something that's not actually there.
So they're checking if the AI is making things up.
Exactly.
Pretty clever. What about domains beyond music?
So in daily life scenarios, they tested things like judging the distance of a sound in a spatial audio recording, or figuring out what someone is doing in a video based only on the sounds. And get this, they even tested the AI's ability to understand why a meme is funny based on the visuals and the sounds.
Whoa. I am starting to see how diverse this benchmark is. And it uses a multiple choice format, right?
Exactly. That keeps the evaluation objective and avoids the need for like subjective human judgment.
Makes the results more clear cut.
Exactly.
Okay, so after all this build-up,
Yeah.
how did the AI perform on this massive AV Odyssey? Did any of them manage to impress?
Well, here's the truth. Even with all of the advances we've made in AI, the results were pretty humbling. The top performing model only reached 34.5% accuracy.
34.5%. That's even worse than dev test.
Yeah.
It seems like AI still has a lot to learn about audiovisual comprehension.
It really underscores the sheer complexity of this challenge. And when the researchers dug deeper into the results, they found that the MLMs were struggling with a few key things.
Like what? What were the main stumbling blocks for these AIs?
Well, one major issue was connecting audio and visual information. Models that are trained on separate data sets for audio and visual data really struggled to integrate those two modalities effectively. It's like they're trying to solve a puzzle,
Uh-huh.
but like half of the pieces are missing.
So they're learning about sight and sound separately, but they're not good at putting those two things together when you need to.
Exactly.
Right.
And remember how poorly they did on those basic listening tasks in DEF test? Well, a staggering 63% of the errors in the AV Odyssey benchmark could actually be traced back to the AI simply misinterpreting the sounds themselves.
Wow. It's like they're not really listening at all. They're just processing sounds without truly understanding them.
Exactly. It suggests that current MLLMs might be leaning too heavily on pattern recognition and statistical correlations, without truly understanding the meaning behind the sounds that they're processing.
This is where things get really interesting for me. because it raises a big question. Can we learn from how humans perceive audio and visual information to design better MLLMs?
Ooh, that's a question that goes to the heart of this research. And we'll be digging deeper into that in part 2.
Can't wait. This is some seriously mind-bending stuff. I'll see you then for part 2.
Welcome back to our deep dive into the world of multimodal large language models. And you'll recall that we've been dissecting this fascinating research that challenges whether AI can genuinely understand audiovisual information. And we left off talking about the AV Odyssey benchmark and how even the most advanced MLLMs struggle to perform well.
Yeah, it was definitely a reality check. But you know me, I'm always looking for that silver lining. Even with these limitations, this research feels incredibly valuable. It's like they've given us a roadmap for where AI needs to improve.
I totally agree. Pinpointing those weaknesses is the first step towards addressing them. And the paper actually offers some potential explanations for why MLLMs are falling short. One key insight is that the way these models are trained might be part of the problem.
Okay, now you've got my attention. Training is like AI boot camp,
No.
right? Where they learn all their skills. So what's going wrong in boot camp?
Well, a lot of MLLMs are trained on separate data sets for audio and visual information, so they're learning about these modalities in isolation. And that could be hindering their ability to connect the dots when they're faced with real-world scenarios where audio and visuals are all mixed together.
So it's like they're learning to speak two different languages, but they haven't figured out how to translate between them. Makes sense why they'd have trouble following a conversation.
That's a great analogy. And remember how we talked about those basic listening tasks in Deaf Test and how poorly the MLLMs performed? Well, the researchers found that a whopping 63% of the errors in the AV Odyssey benchmark could actually be traced back to the AI just misinterpreting the sounds.
So it's like they're missing the forest for the trees. They're so focused on these individual pieces of information that they're not getting the overall meaning. They're not truly listening, are they?
Precisely.
Hmm.
It suggests that current MLLMs might be relying too heavily on pattern recognition and statistical correlations without really understanding the semantic content of what they're processing. They're missing that deeper level of comprehension that we as humans take for granted.
This is where it gets really interesting for me, because it begs the question, what can we learn from how humans perceive audio and visual information? Could that knowledge help us design better MLLMs?
That's the question that really gets to the heart of this research. The researchers suggest that understanding human perception could be crucial for advancing AI's capabilities in this area. For example, we humans are incredibly good at filtering out irrelevant noise and focusing on the most important sounds in a busy environment. So could we teach AI to do the same?
Right, like when you're at a crowded party. You can somehow tune out all the background chatter to focus on the one conversation you're having. AI seems to have a hard time with that.
Exactly. Or think about how we can often predict what's about to happen in a video based on these really subtle visual cues. We instinctively know that if someone is reaching for a doorknob, they're probably about to open the door, but AI might struggle to make that connection.
It's those subtle, almost unconscious inferences that we make all the time. It seems like AI is missing those. It's like they're lacking that gut feeling, that intuitive grasp of context.
And that brings us to another fascinating point the paper raises. They suggest that current MLLMs might be over-reliant on visual captions, so basically using text descriptions to represent visual information. And this reliance on text could be limiting the AI's ability to truly see and understand the richness and complexity of that visual data.
That's an interesting point. It makes you think about how much we rely on language to explain things. But so much of human experience is beyond words, isn't it?
Yeah.
Like, how can you fully describe the feeling of awe when you see a stunning sunset, or the joy of listening to your favorite song?
Exactly, and perhaps that's why relying too heavily on text captions might be holding AI back. It's forcing them to fit these complex sensory experiences into these neat little boxes of language, when the reality is much messier and more nuanced.
It's like trying to explain a color to someone who's been blind their whole life. Words can only go so far.
Precisely. And that's the challenge and the beauty of trying to build AI that can truly understand the world the way we do. It's pushing us to think deeply about the nature of perception, meaning even consciousness itself.
My brain is officially doing backflips.
Yeah.
So with all these limitations in mind, where does this research leave us? What are the next steps for AI researchers and developers?
Well, the paper lays out a pretty clear roadmap for the future. First and foremost, we need better training data sets that reflect the real world, where audio and visual information are seamlessly integrated, not siloed off from each other. We need to train AI on the messy, complex reality of human experience. not on these sanitized, simplified versions of it.
Right. AI needs to learn how to navigate the world as it is, not as we wish it were.
Exactly. And beyond data sets, we need to develop new algorithms and architectures that are better suited to handling this multimodal information. Algorithms that can capture the subtle interplay between audio and visual cues. Algorithms that can learn from context and make inferences the way humans do.
It's like we need to give AI a whole new set of senses, or maybe teach them how to use their existing senses more effectively.
Exactly. And that might involve borrowing insights from fields like cognitive science and neuroscience. By studying how the human brain processes sensory information, we might discover new principles that we can apply to AI development.
It's almost like we're reverse engineering the human mind to build better AI. That's both exhilarating and a little bit scary, don't you think?
I agree, but I think the potential benefits outweigh the risks. If we can crack the code of multimodal understanding, it could revolutionize everything, from healthcare to education to entertainment. Imagine AI that can diagnose diseases based on subtle changes in a patient's voice or facial expressions.
Or AI that can create truly personalized learning experiences, tailored to each student's individual learning style. The possibilities are endless.
And that's what makes this research so important. It's not just about building better AI. It's about pushing the boundaries of what's possible and expanding our understanding of intelligence itself. It's a journey of discovery, and we're really just at the beginning.
Well, this has certainly been a journey so far. I can't wait to see where it takes us next. Ready for part 3?
Absolutely. Let's wrap things up.
We're back for the final part of our deep dive into multimodal large language models. And we've been exploring whether they can really understand audiovisual information.
Right.
And so far, we've uncovered some pretty surprising limitations in how AI sees and hears the world, at least compared to us humans.
Yeah, it's been a fascinating journey for sure. Filled with discoveries we weren't quite expecting, it seems like even the most advanced AI is still struggling with tasks that we humans find incredibly easy.
It really makes you appreciate the complexity of human perception, doesn't it?
I just
But I think this final part is where things get really thought-provoking. I kind of want to shift gears a bit and talk about the bigger picture, the implications of all of this for the future of AI.
Absolutely. As AI systems become more integrated into our lives, these questions of understanding and perception become even more crucial.
Right, like if we're going to trust AI with these important decisions, we need to know it's not just crunching data, but actually understanding the nuances of the situations it's dealing with. And that's especially true when it comes to audiovisual information, which is packed with all these subtle cues about emotions, intentions, social context.
Love that. Yeah,
Yeah,
it's not just about efficiency or convenience anymore. It's about safety, fairness, and even human dignity.
exactly. And it raises so many questions about how we design and develop AI going forward. Like if AI is going to be interpreting audiovisual data, how can we be sure it's not going to misinterpret things, eventually with serious consequences?
Right, that's a valid concern. I mean, we need to make sure that AI systems are robust and reliable, and that they're able to handle the complexities of these real-world situations. That means going beyond just pattern recognition and developing AI that can reason, learn from context, and adapt to these new situations that they're encountering.
So almost like we need to teach AI to think more like humans, to be able to make inferences, understand implied meanings, and even predict what might happen next based on what they're seeing and hearing.
Precisely. We need to move beyond simply feeding AI massive amounts of data and hoping for the best. We need to be more intentional about how we design and train these systems, taking inspiration from human cognition and human perception.
It's a tall order, but it feels incredibly important to get this right. The potential benefits of AI are huge, but we need to make sure that we're developing it responsibly
Yeah,
and thoughtfully.
I agree. It's a journey of exploration and discovery. And it requires collaboration between researchers, developers, policymakers, and even the public. We all have a role to play in shaping the future of AI.
Okay, so to kind of sum up our deep dive today, we've learned that while MLMs have come a long way, they still have a long way to go before they can truly understand audiovisual information the way we do. We've uncovered some really fascinating limitations, explored potential solutions, and even touched on the bigger picture of what this all means for society.
And as we continue to develop AI, it's essential that we approach it with a balance of excitement and caution. We need to be mindful of the potential risks,
Right.
while also embracing the incredible opportunities that AI has to offer.
I think that's a great point to end on. We've covered a lot of ground today, and I think the biggest takeaway is that the quest for AI understanding is far from over. It's a journey that's just beginning. and it's one that promises to be both challenging and incredibly rewarding.
Couldn't have said it better myself.
Thanks for joining us on this incredible deep dive into the world of AI. Until next time, keep those brains buzzing.